Section 1.4, Equations and Inequalities. Let's start off with some terminology. An equation is a mathematical sentence formed by placing an equal sign between two expressions. An inequality is a mathematical sentence formed by placing one of the following symbols in between two expressions. If you notice in the last two sections, none of the problems had equal signs in them. That's the difference between an equation and an expression. An expression does not have an equal sign, an equation does. An inequality has one of these symbols. The first symbol you'll see is, of course, the equal sign. Anytime you hear the same as, or even just the word is, if is by itself, that would mean an equal sign. Next, we have a less than sign. If you notice, a less than sign does not have a line underneath it, and associated word that you would have with this is fewer than. Next, we have a less than or equal to sign. Notice that there is a line underneath this one. The words to associate with that would be at most, which is very confusing to kids at times. Think about it in terms of money. If I say that I have at most $10, that means the top most amount of money I have is $10. I don't have $10 or more, I have $10 or less. So at most, though it can be confusing, actually means a less than or equal to symbol. And you also have no more than. If I have no more than $10, that means that I don't have $11, I only have $10 or less. I have no more than $10. So those can be very confusing. The next one is a greater than symbol. It does not have an equal to sign underneath it, so it's strictly just greater than. You might see words like more than for a greater than symbol. And the last one would be greater than or equal to. So again, it has the line underneath it. So you might see things like at least. So again, this can be confusing because kids see the word least and they think less than. But if I, again, think about it in terms of money, if I say I have at least $10, that means the absolute minimum amount of money I have is $10, but then I could also have more than 10. So at least would mean $10 or more, so greater than or equal to. No less than is another one that tends to trip people up because they see the word less. But if I again associate with money, if I say I have no less than $10, that means I don't have $9, I have more than $10 or equal to $10. So no less than is a greater than or equal to symbol. Let's look at some examples. In your homework, you're going to see a lot of these kinds of problems where they'll give you a sentence and you need to translate it into an equation or an inequality. So let's read this first. It says the sum of twice a number r and 3 is 11. So let's dissect these words. It says the sum, which means addition, of twice a number r. So twice to me would think that I'm going to be multiplying by 2. So twice a number r and 3. So I'm going to take twice a number r and add it to 3. So let's do that. 2r and add it to 3. And like I said before, if ever you see the word is by itself, that actually means equal. So is 11 would mean equals 11. Number 2, the quotient of a number n and 2 is at most 16. So here again, I have a quotient, which means to divide. So the quotient of n, so n divided by 2, is at most 16. So think about it like money. If I have at most $16, I would have $16, that's my top most amount of money, or less. So I would do less than or equal to 16. The next one gets a little tougher. Number 3, a number q is at least 5 and less than or equal to 17. This is actually a compound inequality. Compound inequality means I'm going to put two inequalities together as one statement. But let's first write them as two individual statements. A number q is at least 5. So if something is at least 5, so again thinking of money, if I have at least $5, that means I have $5 or more. The least amount of money I could have is 5, so $5 or more. So my inequality would look like q is greater than or equal to 5, because again, at least means greater than or equal to. We also know that q is less than or equal to 17. So with these two individual inequalities, I want to write it as one compound inequality. The way you do this is you start with the inequality that is the less than or equal to symbol. So I'm going to rewrite the q is less than or equal to 17. If you really read the problem, if something is supposed to be greater than or equal to 5, but at the same time less than or equal to 17, that would just mean that q is literally between, whatever value q is between 5 and 17. So that's what we're going to make our compound inequality look like. We want to take this q is greater than or equal to 5 and put it so that it's combined with the q is less than or equal to 17. So what I'm going to do is just kind of act like this less than or equal to 17 isn't here and only concentrate on the q is greater than or equal to 15. I only have one place where I can put this 5 now, which would be in front of the q. So if I take the q is greater than or equal to 5 and flip it around so that the 5 is on the left and the q is on the right, I'm also going to have to flip the inequality around. So literally, as we said before, if something is supposed to be greater than or equal to 5, but at the same time be less than or equal to 17, that means that q, the number, would have to be somewhere between 5 and 17. So literally, when we wrote our final compound inequality, q is sitting in between 5 and 17, and that would be our final answer. And for clarity's sake, let's look at this together. So we had q is greater than or equal to 5. If you read this from right to left now, it still says q is greater than or equal to 5. We just flip that sign around, so now it looks like a less than sign because we put the q on the right side rather than the left side as it was before. And here still says q is less than or equal to 17 as it said. So we didn't do anything to change the problem. All we basically did was took our first greater than or equal to inequality and just flipped it around to make it into one compound inequality. Let's look at another problem with a compound inequality. Example 4, the sum of x and 3 is at most 17 and more than 5. So let's do the two parts. The sum of x and 3, so x plus 3, is at most 17. If I have at most $17, that means I have $17 or less. So it'd be less than or equal to 17. Our second inequality says that the sum of x and 3 is more than 5. So here again, x plus 3 is more than, so greater than 5. It doesn't say equal to 5, just that it's more than 5. If I have more than $5, I don't have $5, I have more than that, so at least 6. So let's put these two inequalities together into one compound inequality. Like we did before, the first thing we're going to do is write down our less than or equal to, or just the less than. It doesn't have to have an equal to symbol. Let's do our less than inequality first. X plus 3 less than or equal to 17. Now remember, I'm going to now take our other inequality that was x plus 3 greater than 5. And what I'm going to do is take this symbol, flip it around, and put the 5 on the other side. So again, it's as if I'm just taking this inequality and flipping it around. Instead of the x plus 3 being on the left, I'm going to put it on the right. So let's put the 5 over here. I'm moving it from the right to the left, and then in order to do that, I have to flip the sign. Notice when you do this compound inequality, in the end, your two inequality symbols end up both looking like less than symbols. And that would be our final answer. 5 is less than x plus 3, less than or equal to 17. Let's move on to example 5. Sarah enrolled in a guitar class. The enrollment fee was $25. She paid a total of $70 for the enrollment fee and 3 lessons. Notice that they don't tell you how much each lesson was worth. So let's just start dissecting the problem. If it says that we had a total of $70, anytime you total something, it means you added everything together, and it equaled $70. So in our equation, it would have to look like something is equal to $70. And again, since I total it, I know I'm going to have a plus sign in my equation. But again, I don't know how much each lesson was worth. So let's let L be the cost of each lesson. Okay, so again, I'm totaling it. The total came from taking that $25 enrollment fee and adding to it the cost of the 3 lessons together. Let's say each lesson cost $10. So she took 3 lessons, so I would take 3 times 10. But in this case, we don't know what the cost is, so we're just going to take 3 times L since we don't know what the cost is, and we've defined the cost as the variable L. So here's my equation. If she just wants to know what she paid in total for the cost of the 3 lessons, like problem A states what is the cost of 3 lessons, all she would have to do is take each side, subtract 25. So the 3 lessons would equal $45. So in total, the 3 lessons cost her $45. And then problem B says, how much did each lesson cost? Well, if all 3 lessons combined cost her $45 and she did 3 lessons, I'm just going to take 45 divided by 3 to find the cost of each lesson. So 45 divided by 3 is $15 per lesson. And finally, our last problem, number 6. Tyler would like to make no less than $610 selling coffee mugs online. If he sells 28 mugs for $22 each, will he achieve his goal? So let's first dissect this problem into the words that they are giving us. I first see this expression no less than $610. The amount of money that Tyler wants to make can be no less than $610. If I were to say to you that I have no less than $610, that means I have $610 or more. So the amount of money that Tyler wants to make, let's just call the amount of money he wants to make M. M can be anything greater than or equal to $610. You're then told that he sold 28 mugs for $22. If he sold 28 mugs for $22, that means I would take 28 times 22 and see if he's reached his goal of more than or equal to 610. 28 times 22 is 616. So that is more than the 610 goal that he had. So yes, Tyler would achieve his goal. Hooray, Tyler. As always, make sure you jot down any questions that you have about this section that we can go over when we meet again. I would especially take a look at those compound inequality problems and make sure you have all of that figured out. Otherwise, make sure you ask me when we get back into class.